In this video, we're going to take a look at how we can verify that a quadrilateral is a parallelogram. So if you take a look at all of those theorems and definitions back in 6.2, if parallelogram, then make a bunch of conclusions. If you swap the if then, that's the converse. Turns out those are also true. So if all opposite sides are parallel or all opposite sides congruent, etc., 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 one is just a little different here. You have one pair of sides that is both parallel and congruent. Then for any quadrilateral, it's a parallelogram. So the questions will be asked slightly different in this section than in the last section. Instead of saying, hey, here's a parallelogram, go find some measurements, they will say, here's some measurements. Is this thing a parallelogram or not? Or they might rephrase that question to be something like, what would the measurements be in order to make it a parallelogram? So just to show you a couple of quick examples here, to determine if any of these are parallelograms, we can use any one of these 6 tests. So just I want to emphasize the all part here. You need all opposite sides parallel or all opposite sides congruent. You can't have just one pair. So looking at this first one here, I've only got one pair of sides that is congruent. So those are opposite and they're congruent, but I don't know about the other, so I cannot conclude that this is a parallelogram. Here I do have those opposite sides congruent, the other pair congruent, so yes, this would be a parallelogram because all opposite sides are congruent. Over here I've got an opposite pair of angles and another, so all opposite angles are congruent, so yes, that would be a parallelogram. Down here, if I look at those measurements, oh, same thing. So that also is a parallelogram. This one in the middle, I don't know anything about the opposite sides. I don't know if they're parallel. I don't know if they're congruent, nor do I have anything about angles. But I do have that those diagonals are both bisected. So if both diagonals bisect each other, then yes, this would be a parallelogram. And then here I only have something about one pair of opposite sides. I know that they're congruent because of those tick marks, but also those little arrows tell me that they're also parallel. So that's that one kind of different test that we haven't seen back in 6.2. If you've got one pair of sides, both parallel and congruent, that will make this a parallelogram. So yes, that would be. Now they might ask you to verify if a quadrilateral in the XY plane is a parallelogram using one of these 6 tests. If they don't specify which test, I would always go to this one. The reason why is because in the XY plane, to verify that the diagonals bisect each other, you just use that midpoint formula, which is probably one of our simplest formulas we're going to see all year, average of x, average of y's. So you can just check the midpoint of both diagonals, and if they have the same midpoint, that means that they bisect each other. Now that's if they don't specify which test. If they do, then you have to use the test that they ask for. So for example, let's say I have A, B, C, D with those vertices. So I'm going to make a quick sketch just to have an idea of where all this is. 2, minus 1, and okay, so it kind of looks like it's going to be a parallelogram, but we need to verify using one of those tests. Here they're saying using the distance formula. That means that you would have to verify that all opposite sides are congruent. So here's A, B, C, and D. So let's check AB. Now you can use Pythagorean theorem. That right triangle has sides 1 and 1, 2, 3, 4, 5. So that's the square root of 1 squared plus 5 squared. So square root of 26. Let's check DC because those sides are opposite. If DC isn't congruent to that, we can just stop right there because we found one pair of opposite sides that are not congruent. 1, 1, 2, 3, 4, 5. Okay, so DC and AB also have the same length, so now we have to check the other sides. So CB, using that distance formula, up 1, 2, 3, 1, 2. So 3 squared is 9, 2 squared is 4. It's like the square root of 13. And then last one, AD, 1, 2, 3. Okay, so kind of the same thing. So yes, it would be a parallelogram. So we'll say yes, all opposite sides congruent. Oops, congruent. Now I had to use that distance formula because they specifically asked for it. If they were to ask the same question here, these have slightly different coordinates. My graph is messed up. Using slope formula, all you're going to do is calculate the slope of one side, make sure it has the same slope as the opposite side, because same slope means parallel, and then you want to do the same thing for the other two. I'm not going to walk through that one because I know our slope formula isn't all that incredibly technical. The last one I just want to show, this is when using the midpoint formula, this goes the quickest. Just make sure that you look at the diagonals and not the sides. So you want to check the segment from A to C. So you're going to use that midpoint formula. 2 plus 6 is 8 over 2. 4 plus negative 3 is 1 over 2. So that gives you 4 comma a half. Now that's the midpoint of AC. If that has the same midpoint as BD, then the diagonals bisect each other and you have a parallelogram. So let's see. 8 plus 0 is 8 over 2. 2 plus negative 1 is, oh, look. Okay, so they have the same midpoint. That means, yes, it is a parallelogram since the diagonals bisect each other. That should give you more than enough information to get started on 6.3.